Okay, so when we talk about force equals mass times acceleration, there's one universal constant on the Earth that acceleration equals, and that's talking about gravity. So we can take F equals ma and use F equals m times g, being that g is the acceleration due to gravity. So when we have our g here, that's the acceleration due to gravity. This is the formula that's on your data sheet, okay? So look and see that you can find that formula on your data sheet. Normally we just say it's Fg, and that's like g is the subscript right here, so it's meaning the force due to gravity is equal to m times the acceleration of gravity. So this is where Fg is the force due to gravity, and it's measured still in newtons. This is what we call weight. So when we say that we're actually measuring the weight of something, this is the formula that you find. So when you step on the scale, or you say that you're weighing something, what are you actually calculating? No, that's a misuse of terms. Pardon?
Our force due to gravity.
No. You are actually calculating your mass. So it's a misuse in the actual terminology. When you say step on the scale, you are weighing, not you, no, I'm not even going to say that word. You are calculating your mass. So, you know, or whatever, if you say, I went on a diet, I lost weight. No, you didn't. You lost mass. Okay? Weight is the calculated force due to gravity. So when people talk about weight, generally they're misusing the term. Weight is all about gravitational force. So when, say, we weigh ourselves on the moon, that's when you can say, my weight has changed. Because the gravitational force on the moon is different than the gravitational force on Earth. Technically, you would have changed in weight if you changed in mass, right? So,
What if you went in water?
if you went into water, then you're measuring the displacement of the water that overflows.
No. Because
Like sitting in a tub
it's
and
easier to push something in water.
oh, okay, but the gravity, the acceleration due to gravity still stays constant, but in a different medium? For now, we are assuming we are just working with the medium of air. But that's an interesting question. I'm going to think about it. Okay. All right. Very good. So, Fg is weight, but measured in newtons. Mass is mass of object. That's kilograms. So, yeah, even on your driver's license, it says, what's your weight? No, it's supposed to be, what's your mass? Right? No, what's your weight? If it was weight, they would be like, I am 95 newtons. No. Okay? They're all wrong. It's just like saying, oh, I learned by osmosis. No, osmosis is the diffusion of water, not particles or knowledge. Anyways, terminology is very important. Okay. So, mass is the amount of matter in an object. Weight is the force due to gravity. Mass does not depend on a location for a specific object. So if I went to Mars, my mass would be the same, but my weight would be different. Mass is scalar, and weight is vector, because it depends on the acceleration due to gravity, which is down. So, for example, an object has a mass of 22 kilograms and a weight of 36 newtons near the surface of the moon. What is the acceleration due to gravity near the surface of the moon? So, let's see here. Let's say we know about Earth. Our mass is 22 kilograms. And on the moon, what is our mass? Stays the same. The acceleration due to gravity on Earth is negative 9.81 meters per second squared. And it told me the weight. So F net is equal to 36.0 newtons.
Why is it negative? Why is
Oh,
the graph
thanks.
negative?
Oh, and I put something else wrong. Because it's going down toward the center of the Earth. But generally, yeah, I tell you when it changes. Sorry, I put this in the wrong space. FG is in reference to the moon, it told us. And a weight near the surface of the moon is 36 newtons. What is the acceleration due to gravity near the surface of the moon? Do I need any information about Earth to solve this problem? Do I? No.
Why is it negative?
What?
Why is gravity negative?
Because it's pulling us toward the Earth, so that's going down.
I
Up
thought it
would
was
be.
when you toss them up.
Well, okay, let's put it as positive, and then. Fine, yes, you're right. You guys are smarter. Right, because only when we're tossing it up do we reference it as negative. Are all of you confused? Are you teasing me again? Only when it's like tossed up or down or launched at a projectile do we say it's negative. Okay, so G is equal to FG over M. Who's got it? Lisa does.
1.63 repeating.
Okay, so to sig digs, what would you say?
So like 6.3 is repeating.
Yeah?
Not just 3. 6.3, 6.3, 6.3.
Oh,
Yeah.
okay, so to sig digs, this is?
What if we put it in a fraction?
No.
Why? Isn't there 3? There's 32.
Yeah, but I can't put a repeating sign.
Oh,
I need to round it.
1.64.
Yeah, there we go. Whew. Rock on.
Any direction for G?
Well, technically we should. So, G is equal to 1.64 meters per second squared. And just let's say it's going to, well, how do we say this? It's like going down into the center of the moon. So how do we summarize that?
To the moon?
To the moon! No. It's like, that sounds magical. So it's like you're on the moon and it's pulling you down toward the surface of the moon.
Near the surface?
Down. Just down? Can we just say down? Does that make sense? Because it's like it's pulling it, so if you were floating, the gravity's still pulling you down towards the surface. Let's say down to surface.
Question,
Hi.
if you put newtons per kilogram, would that still be right?
Yes.
Okay.
But if, say, just know that like when you see it in a multiple choice that the other units are, or in written response, if it tells you to answer 2 meters per second squared, that you just write it in those units, yeah. But those units are still valid and correct, right? Yeah, for sure. Okay, an object has a weight of 84 newtons on the surface of the Earth. What is the acceleration due to gravity on Mars if the same object has a weight of 62 newtons on Mars? So, let's make our categories. Here's Earth, here's Mars.
Oh, I get it.
So an object has a weight of, so Fg is 84 newtons on Earth, and on Mars, Fg is equal to 62 newtons. Okay, so we're trying to find what's the acceleration due to gravity on Mars. Well, what am I missing in my formula? I need to find my mass. Well, I know that mass is consistent regardless of where you go. It's the matter that's in the object. Well, I know the acceleration due to gravity on Earth, it's constant, 9.81 meters per second squared. So I can find my mass of the object and just transfer it to, and apply it to Mars. Okay, so M is equal to Fg over G. That's 84 newtons divided by 9.81 meters per second squared. So mass is equal to 8.5626 kilograms. I think. Is that right?
Yeah.
Okay, thank you. So then I can go and put that and apply it to my Mars. 8.5626. And just make sure you carry everything. Don't round off that value because we're not at our answer yet. So don't round. So now I'm looking for G, which is Fg divided by M, which is equal to 62 newtons divided by 8.56, etc. kilograms. So then my G is equal to 7.2407 meters per second squared. So I have 2 sig digs. So I will put that to 7.2 meters per second squared, or newtons per kilogram. And we will put down toward the surface, or just down is the direction. Okay, so now try the practice problems that I gave